Good afternoon. Today the plan is to go over the file I/O stuff and streams and take a closer look at streams so that we can overload a certain operator so that we can see out and see in our fraction objects. Okay, so the last annoying part of the homework, the code, was a function called input coefficients from main or something, input values from user, or f.print. We really would prefer to just write coutf, just like an int. And so today we're going to fully understand precisely how to do that, in theory. Okay, so let's see what we got. So let's just recall we have the fraction class, and we can create fractions like so. We can create a fraction by default. We can call .print, but calling .print is actually quite annoying. We'd rather just try to do something like cout a, right? That would be much more preferable. Well, it does work, but let's see why that works. Okay. I can cout A, right? But why can I cout A? I can cout A because what does it do to A? What did it do to A? It converted it to a double, right? Yeah. Wait, what did you say?
I didn't say anything.
Oh, okay. Well, then you're right. Okay. It coerced the A into a double, and then it couted the double. We don't necessarily want this. Okay? When we convert to double, we lose some precision. All right? So even though we can convert to double, let's get rid of that functionality for now. And let's see what happens. So we go to our fraction.h, and here's our operator double. We're going to get rid of that. Okay, so now it's trying to call operator double somewhere else. Oh, let's clean the project. There we go. Okay. Now look what it says here. It says, no operator found which takes a right-hand operator of type fraction, or there is no acceptable conversion. So I just got rid of the acceptable conversion. This cout of A worked because it was able to convert A to a double and then print out the double value. But I got rid of that operator double, and now it says basically no operator matches these operands. Operand types are std, ostream, and fraction. So I went over last time, when you write something like cout A, what you're really writing is the following. Operator less than cout A. Something like that. Okay, so does this even make sense? Does this work? Well, let me show you. So let's try this. Ambiguous call to overloaded function. I guess I haven't done this in a while. Let's see. Stream. Oh, okay. Let me. Does that? No, that probably is not going to work. More than one instance of overloaded function matches argument list. Okay, well, you'll see why I tried this in a second. Okay, so let's see where we left off. Okay, so remember with the file I/O, so we'll get back to what I just did with the fraction class in a second. Remember with the file I/O, we have this process here where it says, okay, let's say instead of cinning a bunch of data, we want to grab the data from an input file. Okay, how do we do this? Well, we have to first open the file. We have to test to make sure that the file exists, because if it doesn't exist, then we're not going to be able to grab anything from it. Then we're going to grab data from the file just as if we were doing cin. Okay, this is what's kind of neat about this. And then we're going to push back the values into a vector, and then we're going to print them out, and then we're going to close the file. Okay? So let me actually write this code. Copy and paste it. Okay, so here's my if stream, input data. So the first thing I need to do is number include f stream. Okay, so that's a library that then gives me access to if stream objects and of stream objects. Okay, so this should compile, and it does. Okay, so I haven't created a file called my data yet, but I will in a second. So let's go back to the slides. And I'm doing this so that, just so you know, if you want a starting point for a project or whatever, or for this functionality, you just come straight to the slides and you just literally copy and paste. It should compile, and then you can just go from there. So copy and paste that like so. Now, there shouldn't be a file called mydata.txt. I haven't defined it, so let's see what happens. Couldn't open file. Okay, that's fair. Let's create a file. So where would I create that file? Let's go to here, 10b, 10b, and let's create a text file, text document called mydata.txt. Okay. Now in this file, 1, 2, 3, 6, put in some numerical values. Now let's see what happens. It worked. Okay? So now, did I recompile my code? No. I just reran it. Right? The code already knew exactly what to do. The only thing was the file just wasn't there yet. But it's still going to do the exact same set of instructions. But now that the file is there, it goes down a different path and it loads up each of the values. But you don't have to create any new code, right? The code has already been created. This is a subtle detail, because I remember once, so my mom is a programmer, and she was telling me once that there was this project she was working on, and somebody told her that they changed the file or something, or no, we modified the file, we changed the file, it works now. She goes back and she looks at the timestamp when that program was last modified, and it hadn't been modified. The program worked as claimed, but the actual code itself had not been modified. So the person's claim that they sort of, changed the code, or we fixed the code so it works now, it was missing this subtle aspect, which was, well, wait a minute, there's a disconnect. Maybe the reason the code wasn't working was not because it wasn't logically correct. It may have just been that the file was not formatted in the way it should have been. And so again, you don't have to change anything to do with the code. You merely need to give a file with the right format, and the code works the same as it would have done otherwise. Okay? So when people tell you things in programming, typically you have to really think deep about all the different subtle aspects involved in such statements. Okay? So in this case, even though I haven't changed the code at all, let me change the file. Someone might come along and say, oh my god, the program changed. And you say, no, the program did not change. All that changed was the set of values that were used as input for the file. Okay? The program itself, no recompiling, did not change at all, just its runtime behavior changed because the content of the file is what changed. Okay. So that's how that works. Here's a little warning. On Xcode, I have to put in the full file path name to get this to work. On Visual Studio, you can just do the local path. But by default, on Xcode, you have to do like /users/. this is an option. I believe I changed it once, but in general, this is one of the other subtle differences. The default values in Visual Studio are local directory, and the default for Mac is always this more global one. You can figure this out as you just search for how to reference files relatively in Xcode 4. It shows up how to do this. We do have to test to see if it was a bad file, if we found it or not, which we did. OK. And then in the end here, this is a subtle aspect, which is we need to close the file. This is sort of like calling delete on a heap-based object. Okay? It basically releases a hold on this file so that other processes can access and modify the file. Of course, when the program terminates, it releases all control, but it's just good practice to always throw in open, close, especially because your program may continue to run and another process within your program may want to access the same file. It's just a good idea to always close your file when you're done with it. Okay. Now we get to the cool part. All right, so this is where it gets even more kind of fun, which is, remember that hierarchy I showed you, the class hierarchy? There's the O stream, the I stream, and then all these classes derived from it. Well, the point is that you can write functions which accept a file stream or a console stream as well. So you can write a function which accepts cin or cout or an if stream or an OF stream object. Okay? What is their data type? Their data type is precisely, well, the data type they have, they're all derived from the appropriate iStream or OStream classes. Most of what you're going to be doing with a file or the console is not specific to the file or the console. So for example, here, if you take a look at this function I've written, I want to square a set of data. Now, I could enter that data in from the console, and I could print it to the console, but I may want to just grab data from a file and output it to another file. How would I do that? Well, how I would do that is actually quite simple. I'd write a function which accepts an input stream from some type of object and an output stream in another type of object. Okay? Whether it's a console stream, a file stream, or what we're going to learn later, a string stream, doesn't matter because all we're trying to do is read in characters, converting them to ints, and then outputting, transforming it into a squared and then outputting it. Okay? So let's actually, and again, I'm just going to copy and paste this code to demonstrate that it is functional code. Okay? So we write this. Now, instead of, let's do the following. I'll keep all this code here, and then I'll redo it. All right, if stream input data. Now, another thing I can do is instead of creating it by default and then calling .open, I can also construct the object using a file name in the form of in quotation. Okay, so I've combined those two lines of code, lines I think 88 and 89, into a single line which says, create a file stream using this file name. And now what I'm going to do is the following. I'm going to create an output file stream. Say output data. I'm going to call it my squared data.txt. Okay? Now I should still check to make sure that I found a valid file. Okay? But then instead of making these calls manually inside of main, what I'm going to do is instead, so here I'm create the stream objects, check for bad file, and then create new file using values from current file. How do I do that? I'm going to call this function here, which is square data. I'm going to give it input data and output data. Now I need to do input data.close and output data.close. It didn't do anything. Did it do anything? Well, what was it supposed to do? Create another file. Oh, maybe I should check to see if there's a different file. Should we check to see if there's another file? Let's check to see if there's another file. Well, look at that. There's another file. What's in this file? That kind of looks like the values of the squares to me. So here, let me put them side by side. 1, 4, 9. I can't do that in my head, but let's just assume that's correct. And then a bunch of 1s. Okay? So there, no console input output. It ran really fast, and you had, but this is now where it gets a little cool. What if I wanted to see the output itself? Okay, let's do the following. So squared data can stick around. By default, it will overwrite whatever data is in the file, so you got to be a little careful. If you're doing calculations and you redo a simulation, it's going to erase the entire file. So if you did a calculation that ran overnight, for example, and then you accidentally reran the code again, and then it will probably just erase all the data that you computed overnight. Okay, so that's where you have to be a little careful. You can set a flag for this, but don't worry about that for now. So let's delete my squared data just to, we don't have to, but just to make sure that we're aware that yes, we're going to lose this data each time we run the program, and it tries to write to the file. Here's something cool. Watch this. Square data, input data, and now rather than, so we're going to print to the file again, as before, but maybe we want to see the values as well on the console. So we can actually input as a parameter cout. Well, that was weird. Oh, because it already read from the file. Okay, let me get rid of this. There we go. Okay, so it went through the file once, and then it got to the end, and then it was at the end of the stream. Don't worry about that so much right now. But okay, so rather than writing to the file, we wrote to the console output. Now, do you think we can do any variation of this that we want as well? So for example, we can write square data. We can do cin, and we can write output data. Okay. How do we get it to stop? I'll just put in a bad value, like A. Then it goes into the fail state, and then it stops grabbing characters from the console. Let's take a look at our file. Okay, so it took the values from the console, and then it calculated the squares, and it outputted the squares to the file. Okay, so the reason this works is because if we look at the input-output structure here, we're accepting two different types of parameters, an iStream reference and an OStream reference. Now, like I said, the console output, cout, is a what is it? Let me pull up the chart just to. Here we go, right there. It is a IOStream. It comes from the IOStream library. Okay, so the file stream comes from the IFStream library or the OFStream library. But because they both inherit from the respective iStream and OStream classes, we can input them into the same function as long as the functions that are called are common to just the iStream and OStream objects themselves. Okay? It's exactly like what concept that we learned recently? Yeah, polymorphism. Yeah. Okay? So there was a question asked last week, which was, how does polymorphism work with references? And I said basically it works exactly the same way. Okay? And here's the demonstration of it. You're passing in a file stream object. It's not getting sliced away because you're inputting it as a reference. So it's being passed in, and only those attributes of that file stream which are known to the iStream class are being called and utilized. And it's not being sliced away, it's not being converted or into anything else. It's just using principles of polymorphism. Okay? So in that respect, this is actually really nice because now we can overload certain operators. For example, if I go to our fraction class, there's a really nice operator we can overload, and it's called, let's see, do I want to make it, I want to make this a friend. Okay, I'm going to make this a friend. It's called operator less than. So we want to be able to write cout less than, and then a fraction object. So this has to be a non-member function of fraction. It can't be a member function of fraction. So we're going to input some parameter for the left-hand side, something like cout, whatever that class object is, whatever class it comes from. And we're going to have a const fraction reference on the right. Okay, so this we want to be able to write cout f like this. So this is going to be the same as operator less than cout f, something like this. So what we need here is an OStream reference. Okay, call it out. What is this OStream reference? It's the same OStream reference that will work for files as well as the console. This way, if we wanted to print the value of f to a file, we can call the same function. We don't have to write a separate function because it only invokes the same base class functionality that is common to both the console objects and to those file stream objects. Now the return type is going to be an OStream reference. And the reason is because we want to be able to do things like cout f less than end out. We want to do operator chaining. Okay? So the return parameter allows for operator chaining. Okay? Now finally we make it a friend because it needs to access the numerator and denominator of the fraction. Okay? I'm going to get rid of that print function. I really dislike the function called print. I want to get rid of it as soon as possible. Okay? So instead we're going to take the code from print and we're going to give it to this operator like so. Oops. Okay. Now, instead of couting this, we're just going to out it. Okay? Now I need to return the stream as well. Okay? The other thing is this is a non-member function, so I need to write f dot and f dot. Now it works. Okay? So now when I go to source, I have all my file stuff here. So let's ignore the file stuff for a moment. Let's go back to our fraction objects, and let's see what happens. So we write fraction A, 1, 2, fraction B, say 7. Now watch this. Cout A and L, B and L. It compiles and it prints it out. Okay? The cool part is the following. Let's put the streams back in. Let's take output data and let's give it A and B. And let's forget this other stuff. Okay? Now let's see what happens. I still see the console output, but if I go to my squared data, it wrote the fraction to the file automatically. I didn't have to write different set of code for the console or for a file. One set of code, and it handles input output for any stream object. Okay? As long as it inherits from the OStream class. Okay? I can do the same thing with cin. So I can cin a point A as well. Okay? So this is also in the lecture slide. So let's see. Don't worry about this beautification of output. Okay? So there's a problem on your practice exam that does this type of thing. I'm not going to ask you about this round. Okay? So your exam is on Wednesday. It'll be in this room. But I won't ask you. I won't ask you about this beautification of output. Separate file compilation definitely could be on there, because I went through that last time. Okay, but I thought there was a C in. Maybe that was lecture 8. Okay. Let's go to 10b. Okay, so iString stream and operator overloading. So this is the lecture on, so ignore that slide. This is the lecture that tells you exactly what I just went over right now, okay? Which is we can create a function as operator overloading of operator less than, which allows us to write things like cout less than A, or write to a file, okay? We can also do the same thing with cin, or file input. Okay, if we want to grab a fraction from a file, and we know the format the fraction is going to be in, we have the following code, which I just took from your book. But what does it do? What it does is, it's a little more complicated than just couting a fraction, because maybe your fraction was inputted as just a 5, and you want to convert that to a 5 divided by 1. Maybe the input was 5 divided by 1 or 2 divided by 7. Basically, we need to be able to detect the different types of input. Okay? So that's what this does here. So let's just look at this code real quick to get an idea of just the basic command structure for basically the two different types of way to input a fractional value. So what we want to do is the following. We want to grab the first integer no matter what. Okay? So if we look, in greater than num. Now it's not cin num, it's just in, because this could be a numerical value from the console, it could be from a file. It doesn't matter. There's just a collection of characters, and we want to grab the first integer value from it. Your intuition is exactly the same as cin, but it just works more generally now, which is nice. Okay? So you grab the first number. Now what you want to do is you want to look at the next character. Okay? That's what get does. Get takes away, so it gets the next character, and it actually does take it out of the stream. When you do things like in greater than num, it pulls those characters out of the stream. And then in this case, it assigns it to num. Get does the same thing. But get is nice because get takes it out of the stream, but gives you a very easy ability to put it back. Okay? So it's kind of like a peek. There is a function called peek as well, but get actually takes it out of the stream, and if it's equal to the backslash, is that backslash or forward slash? I think that's forward slash, right? Yeah, forward slash. Okay. If it's equal to the forward slash, then you want to grab the next integer after it. Okay? Now, if it's not a forward slash, then you want to put it back. You want to unget it. And then in that case, the denominator is equal to 1. Okay? So that way your fraction has been input as just a 7. And it's implied that it's 7 divided by 1. Okay? And then you can assign. So this is the way your book does it. This is not how I would do it. Let me explain to you why. I don't like the idea of overwriting the current value of fraction. You can do it, but let me show you how I would do it. I'm going to copy and paste this code. Let's go to fraction. So this, we made a friend. And again, we have to write the exact function style of, this is the output operator. At param, out is the output stream. At param, f is the fraction object. At returns, the output stream for chaining. OK, this other stuff here, we can put it, say, over here, just as a note. OK. Now, the same thing with the cin operator. So, oops, copy that. We're going to make this a friend as well with its own set of comments. OK, and because we're making this a friend, now the other thing to keep in mind is, do I want a fraction reference or a const fraction reference? Why const? Or why not const? That is the.
Because you're going to modify fraction.
Yeah, so whereas the cout, or the output operator does not modify the fraction, so it's const, this input operator does modify the contents of the fraction object, so we do not want it to be const. And in fact, do we want to pass it in by value? Would passing it in by value be OK? No. Yeah, because if we pass it in by value, it still doesn't let us modify the actual contents of the fraction object. Okay? So we're passing it in by reference because we have full intention of modifying it. OK, so I don't have to do too much here, but when you copy and paste the code, quotations usually get a little different. OK, so let's see this here. Now, instead of this line here, which I dislike tremendously, I'll just do a dot, what did I call it? Numerator and denominator. OK, we're just going to set a dot numerator equal to num and a dot denominator equal to denom. Whoa. Oh, yeah, when you copy and paste, do you want to resave as Unicode? I don't want to maintain my data. Let's see. No. Let's try this again. Missing before. Ah, there's a typo. Oops. Cancel. OK. Now, let's see what happened. So this is within the fraction class. Now I go to source. And it doesn't seem to like this. Let's see. Oh, no, it does. OK, it's fine. OK, so here we go. Now it wants me to cin the value of a. So I'm going to change it to 3/4. Now let me take a look at my file. Now my file should grab the new value of a. The new value of a, or 3/4, should be now in my file. And there's my 3/4. Okay? So I could do this again and input a value of 27. So I have to reload it. So let's X that. And now we reload it. And there's my 27 divided by 1. Okay? So I've got this really nice functionality which basically says, OK, well, your fraction object is now pretty much behaving almost exactly like what? an int or a double or any other numeric data type. That is kind of the point of what we're trying to do here. Okay? And what makes it even more elegant is the fact that we can work with input-output, not just with the console, but more practically speaking with files, input-output. This is what I do. When I do my research and I do some number crunching, I don't write to the console. I write to a file. If I grab data, I grab it from a file. If I output data, I output it to a file for quick reference later on. Okay? So what I'm telling you is all of your intuition from the console input-output applies pretty much equally well to file input-output. Okay, get and unget like I described. Okay. Now there's one other type of, so let me just rephrase the following. I will not ask you about iString stream on the exam. That's coming up Wednesday. iString stream will not be on the exam. But this operator overloading of this input operator and the output operator is fair game for the exam. And on your practice exams that I posted online, you're asked to implement these functions. So now we've gone through them in class, you know how to do them. Okay? But iString stream I will not put on the exam on Wednesday. Okay. Let me motivate the following. If you want to convert a string to an int, that's easy to do. There's a function called a2s, I think. Let me actually show you. If it's a single string, there is a really nice function called, this is new in C++ 11, I think. Let's just get rid of all that. Okay. A2, is it A to S? No, it's S to I. Yeah. S string to int is what that's mnemonic for. Let's do the following. Int A equals that. Int B equals 5, 4, 3, 2, 1. And I get a bunch of 6s. Okay? So if I want to take a string of digits, there's nothing numerical about the string 1, 2, 3, 4, 5. That is just a collection of characters that happen to look like the numerical values that we're used to working with. But then I call the function s to I, and that returns an int value, an integer variable, an int variable that is the equivalent to the numerical value of 12,345. Okay? Same thing with b. Okay? Because you know the difference between, if I were to try and add the strings, what's going to get printed out first? I have to write string in front. If I add two strings together, what does it do to them? It concatenates them. But if I want to take those strings and interpret them as numerical digits, as digits in a numerical value, there's this s to I function. I can go the other way as well. If I have a value, let's say c equals 1, 2, 3, 4, int d equals that, and I want to do string s equals 2 underscore string, I can give it a value like c plus d, s, print out s, and I get the numerical value as a string of digits. So this s is a string variable. It calculated c plus d, and then it converted that numerical value into a sequence of digits and gave that to the string object. Okay? So s now contains all of the digits in the string. Okay? But a lot of times, in a file, for example, if you ever do anything with, In applied mathematics, there's a lot of examples, or even nowadays in computational sciences, tables of values. You have literally databases full of tables of numerical values. And so you need to be able to extract like a single row, and then each of the numerical values is separated by like a tab or a comma. And so you need to be able to quickly extract off a line of text. It's just a string of characters, and you want to pull out each of the numerical values separated by the tab or comma. Okay? So there you're not just converting a single numerical value or a single set of characters into an int. You need to convert an entire row of characters with a separation character into, say, a vector of numerical values. That is the most common thing that you will ever do when dealing with file input-output. And vice versa as well, right? You have a vector of ints. You want to convert that to maybe a single line of characters included with all the digits separated by commas, and you want to put that entire line into a file, and then put the entire next line into a file, et cetera, et cetera. Okay? So how you would do that is through what's called a string stream. And what is a string stream? It is exactly like every other stream. It uses the operator greater than, just like cin, just like our file input structure. Okay? So what do we do here? We initialize a iString stream object using a string of presumably digits. Okay? So for example, think of a console input of 1, 2, 3, or 1 space, 2 space, 3 space, 4 space, 5. So you input that entire string into the stream object, and then what you do is you grab the first character, the 1. Now when you cin a single int, it reads the character 1, and then when it sees a space, what does it do? It stops reading, right? If you're going to cin an int value, you put in 1 space, 2 space, it sees the 1, it stops reading, and then you're good. So if you wanted to read an entire row, you just put in a loop here which says while str greater than n, keep grabbing values. Let me demonstrate. Okay, so these are for single values. Let's say, for example, I had a string s equals 1 space 2, 3, 4, 5, 7. What I would do is I would create an I, and let's say I wanted to make a vector of ints of 6. I created iString stream object s, str of s. Now what I want to do is while s is grabbing values, so let's put in temp. Actually, you know what? Let's just make v unknown size. Okay? V dot push back the value of temp. Okay, so I need to say int temp. Now, I'm getting a bunch of errors because, I believe it's because I didn't actually write number include s stream. No? What did I do wrong? Let's see. iString stream. I wrote s instead of str. Okay. Yay. It worked. Okay, so this is why I need not just to convert a single value, a single string with digits to an int, but if I have an entire row of values separated by a space or a return carriage or whatever, it's easiest if it's a space or a return carriage because think of the console input, that's exactly the same intuition. What I get here is, okay, while the string has characters to give you, which are valid characters, pipe them into the variable temp, and then v is going to push back that value that temp has. Then you're going to repeat, and so this is exactly like writing cin greater than temp. This will continue until the stream either goes into an invalid state or until it reaches the end of the stream. So for example, what would happen if I put in an invalid character here? If I did a 3, 34, 54, if I put in an A, once it reaches the A character, it's no longer returning a valid state, just like cin would do, and then it stops. So it stops at the 54, but the vector v still has all of those elements up to the 54. Okay? Now similarly, what's another thing you can do to separate entries? You could put in return carriages. So instead of a 7 with a space, I could put in a return carriage. I could put in as many return carriages as I want, as many spaces as I want. But it's still going to go until, still going to do the same thing, because it's behaving exactly the same way as the console input would behave. Okay? So a good exercise might be, perhaps on a future homework assignment, it may be to read in, not a matrix, don't freak out over the word matrix, a table of values, and then do something with that table of values. A table of values is usually stored in a file. What you do to that table, probably you want to output to another file. Okay, so this would go along with the practice of you have data in a file, you need to extract the numerical values even though it's really just a string of characters. Here are several tools with which you can extract and get at the numerical values using it, and then use it to take the table and find all the entries that are less than 5 or something like that. Okay? So this is how you do it. This string stream class is the way to do it. Okay? And in particular, what's really nice about it is that it also inherits from... Okay, almost done. This iString stream class also inherits from the same classes that IFstream and IOstream inherit from. That's what makes it so advantageous to work with. Okay? The exact same intuition will apply. So let's end on this idea of, okay, just like you can do an iString stream to mimic cin, you can also do an OString stream to convert from an, to convert from an int to a string of digits. Okay, so if you want to convert a numerical value into a string consisting of all the digits, that's what the OString, stream does. Exactly the same way that cout does it. When you call cout on an int variable a, which has value 5, 5 is not stored as a string. 5 is stored as a bunch of zeros and ones somewhere. But the cout converts that sequence of zeros and ones into a character, a set of characters, and in that particular case it would be a 5. So here it's the exact same thing. You take an int value n. How it stores an int value internally, you have no idea. Well, I could teach you, but it's in one of the slides that we're not going to cover this quarter. But the point is you don't need to know, because this operator takes a numerical value and gives you the ability to output a string of those digits. Okay? That's what's valuable, because then you can go back and forth between numerical calculations and reading and writing from a file. Makes it incredibly easy. Otherwise, to do that manually, you'd have to know exactly how numerical values are stored and exactly how to convert them and extract the digits that you need. Okay, any questions? All right, I will see you here on Wednesday for the first midterm.